So welcome to our April 2025 online lessons. So in this series, we're going to be covering chemical energetics. If you haven't subscribed, please come to our group, pay a small fee, and you're going to get PDF notes, you're going to get audio explanations, you're going to get self-evaluating tests in the form of test maker. So to those that are familiar with the test maker app, you now know what it's capable of doing. It's like I'll cover the following in this series, so you might want to tell a friend to come and join us. I'll cover a section of the syllabus that's called chemical energetics, and I'll explain that chemical reactions are accompanied by energy changes, mostly in the form of heat energy. So this is basically thermodynamics. I will talk about the enthalpy changes of reaction, formation, combustion, neutralization, hydration, solution lattice, and electron affinity. Okay, we'll explain those terms, we'll explain the enthalpy changes. We'll talk about standard enthalpy changes, those that we just listed there. We'll talk about bond energy and lattice energy. We'll talk about how to calculate enthalpy changes from experiments or experimental data. We'll talk about Hess law. We'll talk about Born-Haber cycles. We'll explain the factors that affect the size of lattice enthalpy and many other things. So we're going to do this entire section. So without wasting a lot of time, let's dive straight into the content. So firstly, the energy changes that you're going to be coming across, their names, their definitions. So you must be familiar with what's called the enthalpy change of formation. This is the enthalpy change when 1 mole of a compound is formed from its constituent elements in their standard states under standard conditions. So this is when we form 1 mole. The morality here is important, the stoichiometry here is important. 1 mole of a compound is formed from its constituent elements under standard states and standard conditions. So for example, here we have carbon combining with hydrogen to give us here, this would be H2C2H6 would be your methane. So this would be the enthalpy change of formation of methane. So you can see that your carbon here is given in solid. This would be its state under standard conditions, and hydrogen exists as a gas under standard conditions. And here it's important that we are forming 1 mole. So there are 2 moles of carbon here, 2 moles of hydrogen, but we form 1 mole, which we said here you're supposed to form. You form 1 mole. So it's important to take note of those things. We have another type here that's called the lattice enthalpy of formation. So this is when you form a lattice. So the definition says here, this is the enthalpy change when 1 mole of a solid ionic compound is formed from its gaseous ions under standard conditions. So for example, here we have calcium chloride, and these are the gaseous ions that we use to form 1 mole of calcium chloride. You would have 1 mole of your calcium 2+ in gaseous state. The state is very important. And 2 moles of chlorine chloride ions here in gaseous state to give you a calcium chloride in solid state. So this is your enthalpy change this is your lattice enthalpy of formation. We have another one called lattice enthalpy of dissociation. This is the opposite of the first one, which is your lattice enthalpy of formation. This lattice enthalpy of dissociation is the enthalpy change when 1 mole of a solid ionic compound is dissociated into its gaseous ions under standard conditions. So for example, our calcium chloride we are breaking down into its constituent ions in gaseous state. So this is the lattice enthalpy of dissociation, or simply dissociation enthalpy. Okay, let's talk about the enthalpy change of dissociation. So this one was for the lattice, the solid structure that we form with those ionic compounds. This is the enthalpy change when 1 mole of bonds of the same type of molecule in gaseous state are broken. So this one was specifically for solids. This one This one is just saying when one more of bonds of the same type of molecule in gaseous state is broken, it's called the enthalpy change of dissociation. So you need to be in mind, are you breaking down a lattice, or you're breaking down just a bonds, for example in this covalent compound here in gaseous form. So lattice is specifically for those solid ionic compounds. Okay, so that is where you use this word. Okay, let's move on. The enthalpy change of first ionization. You know that our ionization energies are successive. You remove one electron, one more of electrons each time. So the first ionization energy enthalpy change would be the enthalpy change when one more of gaseous 1+ ions, monopositive ions, are made from one more of gaseous atoms. For example, here this would be your sodium in gaseous form. This is important to give you sodium plus in gaseous form. That's your enthalpy change of first ionization. The enthalpy change of atomization. This would be the enthalpy change when one more of gaseous atoms is made from an element in its standard state. So for example, here I have half a mole of fluorine in gaseous state, giving me one more of fluorine atoms. So half a mole here will give me one more of, the stoichiometry there is important, will give me one more of those fluorine atoms. Okay, so let's move on. The enthalpy change of second ionization energy would be the enthalpy change when one more of your gaseous 2+ ions are made from one more of gaseous 1+ ions. So this would be the second ionization energy. For example, your calcium, so you're starting with the calcium already with a charge of +1 here, moving to a charge of +2. So those are important for you to know. The other one is the enthalpy change first electron affinity. The enthalpy change when one more of gaseous 1-, so this would be for usually your non-metals which accept electrons to give your 1- ions, are made from one more of gaseous atoms. So for example, oxygen here would first accept one more of electrons, or one electron if you want, to give O-1. So this would be the first electron affinity of oxygen. Take note of the states here in gaseous state. The second electron affinity would be when this negatively charged oxygen accepts another electron to give O2-, all in gaseous state. So these are the important enthalpy changes that you're supposed to be familiar with. So go through these, make sure you're familiar with the definitions, and we continue in the next section where we talk about Born-Haber cycles.